Hello students, my name is Mahesh Mahale, working as assistant professor in MEP's S.V.K.T college, Devlali camp, Nashik. So in this lecture we will discuss the topic which belongs to FI BSc chemistry and inorganic and organic chemistry, which is hydrocarbons. In that we will mainly focused on alkanes. So in this lecture we will discuss what are alkanes, what is homogeneous series, IUPAC nomenclature of alkane, classes of carbon, physical constant. So in today's lecture we will discuss these points, and another 2 points will be discussed in next lecture. So synthesis of alkane and reactions of alkane will be discussed in next lecture. So in this lecture you will understand the basic concepts of alkane, such as homogeneous series, isomers, classes of carbon, and physical properties such as melting point and boiling point, solubility, etc. So we will focus on mainly these points. Then we will discuss the IPAC nomenclature of alkanes. Then you will learn about the industrial and laboratory method of synthesis of alkane in next lecture, and reactions of alkane with their mechanisms. So basically organic compounds which are consist of only one carbon and hydrogen, so only carbon and hydrogen atoms are known as hydrocarbons. So basically the compounds, the organic compounds, or basically the organic chemistry which is deals with the compounds of carbon. So in hydrocarbons are basically a concept which consist only carbon and hydrogen containing compounds are classified into hydrocarbons. So hydrocarbons are further classified into two classes, which is aliphatic hydrocarbons and aromatic hydrocarbons. So aliphatic hydrocarbons are those which have straight chain like structures or straight or branch chain like structure, and aromatic hydrocarbons are those which have an aroma, means some smell like odor to their compound. So they have a ring structure in their compounds. So basically hydrocarbons are classified into two classes, which is aliphatic hydrocarbons and aromatic hydrocarbons. So in your syllabus we will discuss the main topics, which are alkanes, alkene, alkynes, and cyclic aliphatic hydrocarbons. So what is homogeneous series? When the alkenes are arranged in the increasing order of their molecular formula, a set of compounds in which the member differ in the composition from one another by CH2, this is unit, CH2 unit, is known as homogeneous series. Means a series of a compound formed by the difference of CH2 group in between them are called as homogeneous series. The member of homogeneous series are called as homologous of each other. So in alkene family their homologous will be differ by a CH2 group. In alkene series similar difference will be observed by CH2 group, and alkyne same. So CH2 group will be differ by in their homologous series. So they are homologous member of series is called a homologous of each other. So the homologous series is observed in all a type of organic compounds containing different functional groups. So we have n number of functional groups such as alkane, alkene, alkynes, carboxylic acids, then ketone, then aldehyde, and so on. So all of these series are, so all these organic functional groups are categorized in are having homologous series. So what are isomers? So isomers are the compound having a same molecular formula but different structural arrangement. So represent different compounds, such compounds are called as isomers, and the phenomenon is known as isomerism. So basically so the compounds which are having a same molecular formula but different structural arrangement are known as isomers of each other. So isomers are differ in their physical and chemical properties. So these three examples will explain the isomerism in between them. So in these three compounds, so number of carbons and hydrogens are same in N-pentane, 2-methylbutane, and 2,2-diethyl propane. So basically three compounds having same number of carbon, that is number of carbons are 5 in each compound, but having a different structural arrangement. So basically in first compound, so N-pentane having a 5 number of carbon in a straight chain in 2-methylbutane, so 4 number of carbons are in a straight chain and 1 methyl group, so CH3 group is at 1 carbon position, so second number carbon position. And in third compound, so 2,2-dimethyl propane in that case, so 3 carbons are in a straight chain and 2 methyl groups are attached to second number carbon. So the structural arrangement are different. So basically isomers are those compounds having a same molecular formula. So in all cases the number of carbons are 5 and number of hydrogens are 12. So in all 3 compounds, so n-pentane having a formula of C5H12, 2-methylbutane having a formula of C5H12, and 2,2-dimethyl propane is also having a formula of C5H12, but the arrangement of a structure is different. So they are isomers of each other. So isomers differ in their physical and chemical properties. So basically their chemical reactivity towards the reactant or any catalyst are different, and physical properties such as melting point and boiling point are different in isomers. So in case of n-pentane, so boiling point is mentioned below there. So n-pentane having a boiling point of 36.1 degrees Celsius, whereas 2-methylbutane having a boiling point of 27.9 degrees Celsius, whereas 2,2-dimethyl propane having a boiling point of 9.5 degrees Celsius. Although all structures having the molecular formula of C5H12, their boiling point are different due to structural arrangement. So all structures are different, but molecular formula are same. So such type of compounds are called as isomers, and the phenomenon is called as isomerism. So there are some examples of isomers. For example, in this case, this is n-hexane. So n-hexane having n-hexane, so there are 6 number of carbons. So 1, 2, 3, 4, 5 and 6 number of carbon. Similarly, this compound which is 2-methyl isopentane, so or 2-methylpentane, so having same number of carbons. So 1, 2, 3, 4, 5 are in one chain and one carbon is branched to that chain. So number of carbons are 6. Similar in case of n-hexane. So next structure is 3-methylpentane. So in above case, the carbon which is branched with the above main parent chain is at a second position. So in third case, so this is a parent chain which is having 5 number of carbon and the one carbon is at 3 number position. Similarly, in case of 2,3-dimethyl butane, so parent carbon chain having a 4 number of carbon and 2 carbons are branched to that parent chain. In similar manner, so there are number of carbon, so there is 6 number of carbon in this structure. So this is 2,2-dimethyl butane in having a 4 number of parent chain, 4 number of carbon of parent chain, and 2 carbons are attached to second number carbon. So all these structures having a same number of carbon, but the structural arrangement is different, means carbon are attached or branched to different number of carbon. So this is an example of isomers having a 6 carbon in their main formula, but arrangement of structures is different. So these are isomers of each other, and this phenomenon is known as isomerism. Nomenclature. So the first 4 alkanes having a special name such as methane, ethane, propane and butane. From the 5th member onward, the name is simple, derived from the Greek or Latin prefix for a particular number of carbon atom in the alkanes. Thus pentane having a 5 number of carbon, hexane having a 6 number of carbon, heptane having a 7 number of carbon, octane for 8 number of carbon, and so on. For example, in nonane for 9 number of carbon and decane for 10 number of carbon. So nomenclature are basically given by number of carbon present in that compound. So if there is one carbon present in that compound, so the name is given as methane. If their number of carbons are 2, then it's ethane. Number of carbons are 3, then it's prop, and the number of carbon is 4, then given name is butane. So onwards, so 5th onwards, the number is given as pentane for 5 number of carbon, hexane for 6 number, heptane for 7, octane for 8, nonane for 9, decane for 10. Alkanes can have a number of isomerism structure, and the name of these isomers are distinguished by the use of prefixes such as n-butane, isobutane, n-pentane, isobentane and neopentane. We will see this by an example. So in order to give a name to a particular organic compound, there are some rules given by an IUPAC. So IUPAC, full form of IUPAC is basically Indian Union of Applied and pure chemistry. So by rules of IUPAC, there are some criteria to give a name to a particular compound. For example, first rule is identify the longest carbon chain. Thus this carbon chain is called as parent chain. So having a large number of carbon is a parent chain. So select a parent chain having a more number of carbon. For example, in this case, so N hep10, in this case there is 7 carbon. So 7 carbon are in straight chain. So this carbon has to be a, so this chain has to be a parent chain which having a same number of carbon. So 1, 2, 3, 4, 5, 6 and 7 carbon. In second example, which is 2,3 dimethyl hexane having a branch like structure. So in this case we have to select the longest chain. So in this case, so carbon number is given as 1, 2, 3, 4, 5 and 6. If we select this chain, say that is 1, 2, 3, 4, this is a minimum number of carbon. So in this chain we get 6 number of carbon, and in this case we get 4 number of carbon. So in order to select the chain which is having a longest carbon chain, that is n number of carbons are more. So in order to follow that rule, we have to select this chain having a carbon number of 6. Then we will select or we will give the name of substituent attached to the main carbon chain. Second rule is the number of carbon of the parent chain from the end that gives a substituent the lowest number. If 2 or more side chains are in equivalent position, assign the lowest number to the one which will come alphabetically first in the name. So in this rule we will give, if we select the longest chain and then we will have a substituent to that longest chain. For example, in this case, so 3-ethyl 5-methyl pentane. So how these substituents are attached before that parent chain we will discuss here. So in this case the number of carbons are 7 in longest chain. So 1, 2, 3, 4, 5 and 6. If there are more than one substituent to the parent chain, for example in this case we have a methane as a substituent, methyl group, and ethyl group as a substituent for a parent chain, then we will have to apply the rule, second number rule, which we will explain, which explains the number of position of that substituted group. So in order to so this rule tells that or taught that the substituent which are, if there are two substituents, for example if we will give the numbering from this side, so 1, 2, 3, 4, 5, 6, 7. So numbering will be in either direction. So in order to give a number in proper direction, the alphabetically which substituent have an alphabetically first number is given first, then the second. So in alphabetical order, E comes first, then M. So in order to follow that rule, we have to give a numbering from this side. So 1, 2, 3, 4, 5, 6 and 7. So in a third position, this methyl, so third ethyl group is present, which is alphabetically first. After that we will number the fifth substituent, which is methyl substituent, so which will have a fifth number position. So this rule, according to this rule, the name of compound will be 3-ethyl 5-methyl heptane. So in order to name or write a name of any organic compound or any hydrocarbon, we have to start with the substituent. So if substituent, alphabetically which substituent will have a less number, will give a number in that order. So 3-ethyl 5-methyl heptane. So heptane is basically a number of carbon. So hept means 7 number of carbon, and oct means 8 number of carbon. So here we have a 7 number of carbon, so that's why the name is heptane. So parent chain will be heptane and these are the substituent. In similar case, here is an example. If this is 2-methyl butane, so actual name of this compound will be so 1, 2, 3, 4. There are 4 number of carbon in that parent chain. The numbering will be given in either direction. So for example in 1, 2, 3, 4 manner, or 1, 2, 3, 4 manner. So this is incorrect, this is correct. Why it is incorrect, why it is correct? The reason is in order to give the number of number to the parent chain, the substituent will have a less number. So in this case the substituent will have second position, in this case substituent will have a third position. So in order to give a number, the substituent will have a less number. So in that case, so this is the correct numbering for so 1 2 3 4. So the carbon number is 1 2 3 and 4, and at the second number of second position there is a methyl substituent. So 2-methyl butane is the correct numbering, so the correct name of this compound, not this. So 3-methyl butane is incorrect. In another example we will discuss that there is 1 2 3 4 5 6 7 8 and 8 number of carbon is there. So parent chain will be octane, so here it is octane. Then we will have to name the name of substituent. So in order to name the substituent, we will have a substituent at third position and we will have the substituent at fourth position. So this is one CH3 group, this is CH2 CH2 CH3 group. So this is propyl substituent, this is methyl substituent. So in order to give that a name, so M come first, then P will followed by P. So name of compound will be 3-methyl 4-propyl octane. So the number of the position of that methyl group will be mentioned first by number, then the name of substituent followed by an hyphen dash, then the position of second substituent which is at fourth position, then followed by hyphen, and then the name of substituent, and then name of parent chain. So this has to be a proper name of this compound, not the numbering will be not given in that manner. That is 1 2 3 4 5 6 7 8. So this is wrong numbering because of the substituent will have longer side of name. So that is so 1 2 3 4 5. So substituent will have a 5 number and a 6 number position. So this is also a one chain, that is 1 2 3 4 5 6 7 8. So why we will exclude this chain? Because in order to number a longest chain, we will have a maximum number of substituent attached to that chain. So in order to get that chain, this chain is a perfect. So this chain having a large number of substituent. For example, there are two substituent at one substituent at third position, one substituent at fourth position. If we will consider this chain, we will have only one substituent. So we will exclude this numbering. So 1 2 3 4 will not possible for this compound. So in order to correct the name of this structure, we will have to select this chain. So 1 2 3 4 5 6 7 8, because of number of substituents are more in this chain rather than this chain. So in order to select any longest chain, we will have to select that chain which will have number of more number of substituent. Similarly, in order to number that carbon chain, the substituent will have less number, and in order to number the substituent, so alphabetically if the substituent will be having a same number of position, for example 1 2 3, similarly if we will give this numbering from this side, so 1 2 3, so there are similar kind of substituents, so third and fifth, similarly third and fifth position. So in that case we have to select the substituent alphabet. So alphabet having a less number will come first, then followed by second alphabet. So E comes first, then M. So in order to get that name, we have to number from this side. So 1 2 3 4 5 6 7 is the perfect numbering. Similarly in this case, similarly in this case. In alphabet, similarly, so as we discussed before, in alphabets E comes first, then M. So 3-ethyl 2-methyl hexane. So this is marks in red. So 1 2 3 4 5 6. So this is the longest chain. If we consider 1 2 3 4 5, so number of carbons are 5. So 7 is greater than 5. So we have to select, sorry, 6 is greater than 5. So we have to select this as longest chain, or 1 2 3 4 5 6. So this is also a similar chain, because having a methyl at the end which will give a same numbering. So either you consider this change as longest chain or this chain as a longest chain. So after numbering, we have to name a substituent. So in order to get a substituent name, so at the third position, where is, so 1 2 3, so at third position there is ethyl substituent, at second position there is methyl substituent. So E comes first. Either the number of carbon is third, but in order to name that compound, so name of substituent by an alphabetical, written in alphabetical manner. So ethyl comes first, so E comes first, then M comes first. So exclude these number during the time of writing the name. So exclude this number. So 3 number position ethyl group is there, second number position methyl group is there, but in order to write that name, we have to write first E, which is comes first, then M followed by E. So ethyl, then methyl. So number of ethyl group is third and number of methyl group is at second position. So the compound name will be 3-ethyl, that is at the third position there is ethyl group, 2-methyl, that is at second position there is methyl group, and then followed by the parent chain. So having a 6 number of carbon, it is named as hex N. So A and E is a functional group basically for alkanes. So single carbon carbon single bond is a kind of functional group which is having a which will end with A and E. Similarly, in case of 4-ethyl 3-methyl heptane, so 1 2 3 4 5 6 7. So largest number of, sorry, the longest shell will have a 7 number of carbon. So if you will consider 1 2 3 4 5 6, this chain having only 6 number of carbon, so this has to be a longest chain having number of carbon are 7. So parent chain will be hept. So for a 7 number of carbon, the short form will be heptane. So the parent name will be heptane. So this has 7 number of carbon, so there the name of main chain will be heptane. So substituents, now the substituent, so substituent will be at the third position and the fourth position. So at third position there is a methyl substituent, at the fourth position there is ethyl substituent. So there are 2 substituent in this carbon in this compound. So at fourth position there is ethyl, at third position there is methyl. So E comes first, then M comes first. So as we discussed earlier, that exclude the number during the writing the name of organic compound. So E comes first, then followed by M. So 4-ethyl, so 4 represent the actual number of position of that ethyl group, that is at fourth position there is ethyl substituent. So 4-ethyl 3-methyl heptane. So name of compound will be 4-ethyl 3-methyl heptane. So during the time of writing the name of any organic compound, the substituent will be arranged in an alphabetical manner. If there is a propyl substituent, so in order to name that substituent, so M comes first, then followed by P. So if in case it is in case of ethyl there is a propyl, so CH2 CH3 group will be there. So either this chain or this chain will be considered, but having large number of number of carbon will be 7, same in both cases. So this has to be a propyl substituent. So in that case the substituent name is propyl. So position of that propyl substituent is 4th number position. So in order to name that compound, so 3-methyl 4-propyl heptane. So if we change the substituent, that is CH2 CH3, this is propyl substituent, the name of compound will be 3-methyl, that is M come first, then P followed by P. So 3-methyl 4-propyl, then heptane. If the same substituents occur more than once, that is the number of substituents, for example methyl groups comes 2 times, or ethyl group comes 2 times, or propyl group came 3 times. So in that case, if the same substituents occur more than once, the location of each point on which the substituent occur is given. So in addition, the number of times the substituent group occurs indicated by a prefix, that is di for 2 times, tri for 3 times, tetra for 4 times, and onwards. If If there are two or more different substituents, they are listed in alphabetical order using the base name. The only prefix which is used when putting the substituent in alphabetical order is iso, as in isopropyl or isobutyl. The prefix secondary and tertiary, that is secondary for sec, tertiary for ter. So trt are not used in determining alphabetical order except when compared with each other. Fifth rule will be, if the chain of equal length are competing for selection as the parent chain, then choice goes in a series too. For example, if there are two number of chains having a same number of carbon, that is if we discuss the example of heptane, if there is a substituent at fourth position, that is propyl substituent, so number of carbon are 7 in two different chains, so number of chain are 2 if the change of equal length, so number of carbon in both cases are 7. In that case, the selection of that change is given by choice. So first choice will be the chain which has the greatest number of side chains, that is extra number of substituent. So first selection of chain will be based on number of substituents, so the chain which have greatest number of side chain. Second selection rule will be the chain whose substituent have the longest number, the substituent number will be longer. For example, methyl is there, ethyl is there, propyl is there. So if propyl is having 3 number of carbon, so chain will be selected as having a substituent which are largest lowest number. So methyl will be selected, then ethyl, then propyl. Third rule is, in that case, so the chain having a greatest number of carbon atom in the smaller side chain, and fourth is the chain having the least branch side chain. So this is the rule if the two chains are equivalent, having equivalent. Sixth rule is a cyclic, that is a ring hydrocarbon is designated by the prefix cyclo. So if there is a cyclic chain in that carbon compound, so the prefix will be cyclo and followed by number of carbon which appears directly in front of base name. So there are 3 examples such as 4-ethyl 2-methyl hexane having 1, 2, 3, 4, 5, 6 number of carbon having a parent chain, and at second position there is methyl substituent, and at fourth position there is ethyl substituent. So fourth position is given because of, if we consider 1, 2, 3, 4, 5, 6 position, so second position it is ethyl and fourth position it is ethyl. So number is name of substituent are written in alphabetical order, so E comes first, then M. So 4-ethyl M-methyl hexane. Similarly, in case of this case, the parent chain having a 7 number of carbons, so 1, 2, 3, 4, 5, 6, 7. So number of carbons are 7 and substituents are 1, 2 and 3. So this is ethyl substituent, this is methyl, this is also methyl. So by rule there are 2 same kind of substituents. So in that case we have to name or add a prefix before that methyl substituent as a di, because there are 2. So in order to write the name of this compound, the name of compound will be 4-ethyl. So having a fourth position 1, 2, 3, 4. So this has to be a proper position from this side. So 1, 2, 3, 4, 5, 6 and 7. So at fourth position it is ethyl. So at fourth position it is ethyl, and at third position there are 2 methyl groups. So in order to write that name, 4-ethyl 3,3. So at 3 position there are 2 substituents. So 3, 3, and there are 2 substituents because there are 2 substituents. So di is written before that name of substituent. So 3, 3 dimethyl heptane. So hept means 7 number of carbon. Ane represent the functional group, that is alkane. So name of compound will be 4-ethyl 3,3 dimethyl heptane. So in this case the number of carbon will be 1, 2, 3, 4, 5, 6, or either 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. So be by this side, because the number of substituents are large in this case. So 1, 2, 3. So at third position there is last substituent, and at fourth position there is small substituent. So in order to get that name, we have to number the chain by either side, this side. So 1, 2, 3, 4, 5, 6. By the numbering from this side, the name of compound will be 3-ethyl side. That is, at third position there is ethyl substituent, at fourth position there is methyl substituent. So the name of compound will be 3-ethyl 4-methyl hexane. Classes of carbon atom and hydrogen atom. It is becoming more useful to classify each carbon atom of an alkene with respect to, first, a primary carbon. Carbon means primary carbon is written as 1 degree at that top, and then so primary carbon. So C represents that carbon. So primary carbon. So carbon atom is attached only one other carbon atom. So primary carbon will be that carbon which is attached to only one carbon. Secondary carbon will be that carbon which is attached to 2 other carbons, and tertiary carbon will be that carbon which is attached to 3 other carbons. For example, in that case, so this this carbon is attached to only one carbon. So this carbon is named as primary carbon. This carbon is attached to 2 other carbons. So this is one carbon, this is another carbon. So this carbon is represented as secondary carbon, and in this case this carbon is attached to other 3 carbons. So 1, 2 and 3 carbons. So this carbon is attached to other 3 carbons. So this carbon is tertiary carbon. So primary, secondary and tertiary carbon. So this is also primary carbon because it is attached to only one carbon. Similarly, this is also a tertiary carbon because it is attached to 1, 2, 3. So 3 other carbons. So this carbon are tertiary carbon, this is secondary carbon, this is also a secondary carbon, this one and this one are basically a primary carbon. In similar case, this carbon has to be a tertiary carbon because it is attached to other 3 carbon. This carbon is secondary carbon because it is attached to 2 other carbon, and these are primary carbons which is attached to only one carbon. So these are primary carbon, this is secondary carbon, this is tertiary carbon. So these were some examples of primary, secondary and tertiary carbon. So these are the classes of carbon atom and hydrogen atom. Physical properties. So physical properties, the normal alkanes having from C1 to C4 are colorless gases, C5 to C17 are colorless liquid, and from C18 onwards they are colorless solid. So basically lower number of carbon family, that is C1 to C4 are basically gases which are colorless. C5 to C17 are basically a liquid form. So C18 onwards they are in solid form. The boiling point and the melting point increases at the number of carbon as the number of carbon atom increases, except for very small alkanes. The boiling point rises from 20 to 30 degrees Celsius for each carbon atom that is added to the chain. For example, so the boiling point are basically differ by a small number. So 20 to 30 degrees Celsius number is we can see that. So as the branching increases, the molecule tend to become spherical, that is the shape of molecule will be changed. So thereby the resulting in decreases the surface area available for their intermolecular interaction. So van der Waals forces are weak in that case, and the boiling point and the melting point. So melting point and boiling point decreases as the branching increases. So we will see this in that case. So in case of N-pentane, so this is a state change having a 5 number of carbon. So this compound having same number of carbon but the branching is different. Similarly, in this case the number of carbon are 5 but branching is different. So as branching increases, the boiling point decreases. As we will see, in case of N-pentane, the boiling point of that molecule will be 36.3 degrees Celsius, whereas in case of 2-methyl-butane having 5 number of carbon and same number of hydrogen, the boiling point decreases. So as branching increases, boiling point decreases. Similarly, in case of 2,2-dimethyl-propane, boiling point decreases at 9.5 degrees Celsius. So boiling point is less in this case. So as branching increases, boiling point of that molecule will be decreased. The increase in melting point is not so regular since the intermolecular force is crystal depend not only upon the size of molecule but also upon how well the molecule is fit in that crystal lattice. For example, in case of n-pentane having a high melting and boiling point than isobenzene but not neopentane. So melting point is high in case of higher in n-pentane. So neopentane has highly symmetrical structure and hence its boiling point its molecular fit well in that crystal lattice. So last 2 points are basically solubility. The alkanes are non-polar and most insoluble in water. So as we know, the water molecule is a polar solvent. So alkanes are non-polar in nature. So they are not dissolved in each other. That is by a principle that is like dissolves like. So polar dissolves in polar solvent, non-polar are dissolved in non-polar solvents. So like that, alkanes are non-polar in nature. So they are insoluble in water and other highly polar solvents, but readily soluble in non-polar solvents such as benzene and ether. So as they are non-polar in nature, they dissolve in or soluble in non-polar solvents. Density, the relative density increases with size of alkane. So as the number of carbon increases, the density is also increases, but not more than 0.8. Thus all alkanes are less denser than water. So all alkanes are basically having a less density than a water molecule. So in next lecture we will discuss the reactions with alkanes and the synthesis of different kind of alkanes.